Good afternoon, everyone. I'm Shantanu. I'm a technical lead at Delhivery. Today, I will be talking about how Delhivery builds 10 million packages in a month in real time using OpenSearch. So I'll be covering three things today in my talk. I'll talk about what Delhivery is, the scale at which we operate. I'll give a brief overview of how our financial applications work, the use cases which we solve, why real-time charge calculation is so essential for us, right? And at the end, I will highlight some of the problems we faced with rising scale, as other speakers have also done so, and the solutions we found out to solve those problems. So firstly, a brief overview of Delhivery. Delhivery is India's largest third-party integrated logistics service provider. So since our inception in 2011, we have delivered over 2 billion shipments. We operate in over 19,000 pin codes. We have 25,000 customers across business verticals. We have 18,000 square feet of logistics infrastructure throughout the country. Our aim is to build the operating system for e-commerce in India. And we are heavily leveraging tech to do this. Now, each package which we deliver is touched by our applications. Right from the first mile, when somebody picks up a shipment, he uses the FM app to scan the shipment. He takes it to one of the facilities. Our facilities are marked so that we can find out where a shipment is in the huge 100 square feet facility in seconds. The last mile applications use some of our patented technologies like AdFix. They help us to disambiguate addresses and reach customers faster. Another set of applications which Delhivery has are financial applications. Now, these applications usually work behind the scenes. They are responsible to calculate shipping cost, invoice clients, and help our finance teams make better decisions. Now, why real-time charge calculation is so important? So say, for example, I'm a customer who wants to ship 10 ACs from Bangalore to Delhi. Now, these 10 ACs should be delivered on time together. And if there is any update throughout the journey of these packages, which might affect the shipping cost, I want to be told of that as soon as possible, so that I can prepare for the same when those shipments are actually delivered, right? Now, say, for example, a shipment is damaged in transit, or it is, worst case, lost, right? We don't want to charge our customers for that. So we want to keep updating our customers with the statuses, and also what is the impact of cost on each action which has happened on a package. So on an average, there are 20 plus updates per package from pickup to delivery. Now imagine the number of packages we deliver in a month, and there are 20 updates per package. Now, it is possible that an update might change a shipping cost as well. Another example of an update which can change shipping cost are weight updates, especially for B2B customers. Now, sometimes B2B shipments are very large to weigh at client facilities. So we get them to delivery facilities, weigh them, and then move them forward. Now, how real-time charge calculation is helping us over here is, say, for example, we see a discrepancy in the weight, which leads to a discrepancy in the freight, right, which is the shipping cost. We want to inform the customer before we move it to the last mile, because we don't want disputes at the time of delivery, because that is too late anyway, right? So we want to inform him well beforehand that this is what we are going to charge you at the time of delivery. This also allows our customers to prepare well, so we get paid faster. Our finance teams, using this real-time data, can spot revenue leakages as well. So they can highlight that if there is a facility which is, say, catching the wrong weight, which is leading to some discrepancies in the shipping cost, we can fix that before it impacts more shipments. So in summary, three things I have to do at every update. I have to first fetch all the shipments which are impacted by the update, as I told you about the ACs, right? Then I have to calculate the shipping costs. Then I have to update the shipping costs on all these documents, right, which will serve all the panels. Now, this should give you a hint of how OpenSearch is an organic use case for delivery in calculating shipping costs. We store our package information on our OpenSearch. We process these updates. We do our calculations through queries, and then we update. So this leads to a lot of searches, a lot of slicing and dicing, a lot of indexing, a lot of aggregations, which are running in real time. Now, billing customers on packages is not very easy, simply because there's so many updates which are coming, which are affecting the shipping cost. So with rising scale, we saw a few problems. Now, these problems are very similar to what other customers have also seen, but we have solved them in somewhat of a different way. Now, one problem was that our indexing latency spiked up. Right? This usually happened during festive seasons. Now, whenever there's an e-commerce sale, right? Whenever there's a big billion sale or Diwali, right? We see the number of packages in our network suddenly spikes up. More packages means more updates. More updates means more calculations, more documents, more load on Elasticsearch, on our OpenSearch cluster. So once the indexing latency spikes up, and if we also noticed that our thread pool queues reached a maximum size. So now, some of the requests which we are getting were actually becoming slow. Some of them were actually getting rejected, right? And another thing which we saw was that some of our data nodes were hot, and some of them were cold. So our entire cluster was not even working to its full potential, and we were actually not serving our business use cases. So these were the few problems which we saw with rising scale. How we went about and solved them is that we revisited our sharding and indexing strategy. We saw that we have a 3-AZ setup, right? And we had 6 data nodes. So we wanted to make sure that all our nodes are split evenly across our AZs. There are a few sessions about hot shard allocation by OpenSearch team today. That is very interesting because it is somewhat exactly what we did at that time. Also, one very interesting thing which we did was at an application level. What we did was that we noticed that there are few updates which come in quick succession, right? So there can be an update on a package within 10 seconds, right, or 5 seconds. We noticed that we do not necessarily need to write every update on our indexes. We can wait for some time, club those updates together in a single payload, and then do the indexing. Right? What this led to was that the size of our bulk requests, right, although increased, but the number of requests went down. So our queues could breathe a little, right? And what we noticed after doing this was that our indexing latency dropped by over 70%. And also, through the shard reconfiguration, our CPU utilization became more uniform. These two things helped us bill our customers in real time. So in summary, through OpenSearch, we have been able to solve one of the most complicated problems in logistics, which is to bill customers in real time, accurately and correctly. Right? I would specifically highlight on the fact that with the AWS OpenSearch team, we were able to perform a lot of infrastructure improvements, which actually led us to actually look also in our application. So as I told you, the two improvements which we did, right, at an infrastructure level, at an application level, were very closely connected. So my key learning from this entire journey with OpenSearch has been that whenever we are optimizing, say, at an infrastructure level, right, it will give you a few hints that what can you do at an application level as well, right, and vice versa. So yes, I'd like to thank OpenSearch for helping Delhivery solve one of the most complicated problems. And I'm excited to also listen to the other problems which other speakers here have talked about, because I see a lot of similarities in the challenges and the solutions which we have faced. Great. Thank you so much.